5,000 sim vendors and loves talking about sim. I'm sure he'd love for you to come talk to me about it at lunch.
Yeah, but I'm not going to talk about Sims today, so sorry to disappoint. What I'm actually going to talk about today is the future. Anton was predicting the future. I'm going to show you the future, which is big data, data mining, and visualization to sort of enable our security intelligence. I'm going to start with this quote here. You make your way through the darkness of abandoned grasses in a search for meaning. As you do, where is the meaning? This is a story or a riddle, or as the Zen monks call this, a koan. This is something that there is a solution to this, but generally it's not a very rational one, right? If I asked you right now what the solution to this is, we could probably have a very long discussion about that, but what you generally do in the Zen community is you meditate with this, and the solution sort of comes to you. And what's interesting about this quote and why I chose this is really because in the security community we have sort of the same problem. We have a lot of data that you can look at. It's right in front of us, it's right there, but we don't really know how to look at it and how to interpret it in order to make sense of it so that we can take actions. Kind of similar to this here. So this is my talk, or a little more readable. Security is getting harder. We have more and more data, we have more stuff to look at, we have more things to understand. We need new approaches. I think maybe coming to the SIM community, security information and event management, or the log management community, I think we have failed as that community, and I count myself as part of that. I have failed as well. I think we need new approaches there, and I think visualization is a very interesting approach in that realm. However, visualization alone is probably not going to solve all of our problems, and what I've been playing with lately quite a bit is data mining, and I'm going to show you how that sort of interplays with visualization. If you look at security analytics today, or the art of analyzing all that data that you're collecting in your environments, here's a little bit of research that I found just about 3 weeks ago from ESG research, where they threw some numbers out there to quantify a little bit of what the problem really looks like. They say that 47 of enterprises that they surveyed like 300 different companies, have more than 6 terabytes of security data that they have to look at a month. And if I asked you right now, who can analyze 6 terabytes of data, just in general, there's probably not very many people that can do that. There are not many products out there, or tools, or approaches that really you can leverage to do this. The other thing that they concluded was that a lot of organizations have a hard time dealing with security data visualization and with security data analysis in general. So let's have a look at this a little bit more. What you see here, this oval here, represents all the data that you have, for whatever purpose, for your security intelligence, for your log analysis. What we have today, we create some visibility into this with known patterns, right? We take intrusion detection systems that have certain signatures. We might have security information management tools that have some correlation rules in there that help us look at things. You might have packet captures or like sort of next generation packet capture tools that try to do some analysis. We have these known patterns that kind of rely on the past, of what we learned from the past, to detect things. Well, so we find a few things that are interesting in here. However, we're missing a whole bunch of stuff, a whole bunch of interesting events, attacks, compromises, information leaks, you name it, because we have been relying on the past to build our rules to detect things going forward. And what's even worse, if you look at this environment now where we miss things, we completely missed the relationships between these different things that we discovered. And we don't really understand the complete pictures. We don't understand what's really going on because we have been missing so many things. But that's sort of the visibility challenge. Now, wouldn't it be nice if we had something like in the movies here, Minority Report, where he has this fantastic interface where he plays with his stuff and all the data that he needs. He moves things around, and in a matter of seconds, he gets to the right answers. Well, in terms of interfaces, this actually exists. Oblong Technologies, I think a Southern California company, is building this as a commercial product to play with these things. It's probably expensive as hell. I don't know, I haven't asked them yet. But what is very interesting to me, has anyone seen this little device that's about this big called Leap Motion? Has anyone seen that? Couple. This is a $70 device. I was able to play with this a week ago. A friend of mine has one. You connect it through USB to your computer. You can use your two hands to interact with the data on your computer. And it basically, this little device here has two cameras inside and 3 other sensors. It detects where your fingers are. It detects the trajectory of your fingers. It detects your hands where they're in space. It's a fantastic device to start interacting with the computer. So we're getting new ways to interact with the data. The problem is just we have to translate this to actual usable gestures and ways we can deal with security data. So as a bridge between sort of the interface and the data itself, we can leverage visualization. Why visualization? Well, to start with, this is the highest bandwidth way that we can communicate data from a system to humans through the whole visual apparatus. What people forget every now and then is why humans are incredibly capable of looking at a lot of different things. And one is, that's why most people look at visualization, is pattern detection. So that you look at something, you can see, oh, this seems to be repeating all the time. Like the graph you saw that Tillman put up, there was sort of the daily pattern, it goes down, it comes back up. We look at that, we're like, oh, yeah, this is because at night machines are turned off, right? Remember context. So like, if I have a security analyst and we look at certain things, and there's suddenly a spike in something happening or a drop in something on Saturday afternoon, a system might alert and say, hey, we have a drop, there's something really bad going on here. But a security analyst looking at this might have more context. He can say, oh, I remember that email a couple of weeks ago where someone said we're going to have a maintenance window on Saturday afternoon. There's all kinds of context that we keep in our minds without consciously knowing about them. Teaching a system all these exceptions and all this context is incredibly hard. Then we have an amazing intuition. We can look at certain things and be like, huh, that's kind of strange. Oh, I bet it's this and that, and we can start to verify whether that's true. Maybe it's a specific holiday, a religious holiday or something, where we can make those interpretations, whereas a machine can't really do that if we don't tell them. So overall, what we need to start doing is we need to enable humans better to solve problems. So we don't need to solve the problems for the humans, for the analysts, but we need to start supporting the analysts better. Now, why is visualization interesting? And why do I think this is the wave of the future? Well, if I gave you these 4 data series here on the left-hand side, they're x, y coordinates. You can plot them on a graph. If I give you these 4 series, I can do some statistics on this. I can have a machine compute all kinds of things. And in the end, if you look at this, the mean, the variance of all of these x series here of the y's are exactly the same. All the statistical properties are exactly the same. The regression lines are the same, the error rates, everything. However, if I visualize this data, it becomes very apparent what I'm showing you here. You see that very clearly. There's a parabola on the right-hand side. You have almost a straight line in the bottom left with one outlier. You have a straight line, a vertical line. And the last one with one big outlier. However, statistical properties are still all the same. But through visualization, this stuff becomes very, very apparent. Why visualization can give us very interesting insights into data sets. Here's an example that I generated from some security data so that you get a little bit of a feel what I'm talking about here. This is from SSL certificates. What I did here is I took the trust relationships between different certificate authorities, and every certificate authority is a node in here. A trust relationship is an edge. You see there's one very big circle out there for one of the certificate authorities. Who do you think that is? It's our German friends. It's the DFN cert, our German friends. And initially I was like, what's this node? Why is this so big? Why does it have so many children? And I didn't know. But then about 3 months ago in one of my visualization classes, I had guys from the DFN cert, and they're like, yeah, we know what this is. And they explained it to me. Well, what happened is, initially, DFN cert signed all of the certificates in Germany directly. But then they said this is not efficient anymore. We want to have sub-CAs that we trust that can then sign the end certificates. So all the universities and certs in Germany now have the capability to sign N certificates. And the DFN cert just certifies all these others. Well, this is sort of an artifact of how I visualize data in here. It doesn't necessarily mean, or it doesn't mean at all, that the DFN cert is trusted more than anything else in here. It's just because I chose the size to be the number of children that this thing sticks out here. What I should have done is choose the size based on the number of N certificates that are being signed by a CA. However, the other thing that's interesting here, so that might explain that one part, but the other interesting thing here is that I have a connection between that upper left cluster going towards the middle there. There's some kind of a connection between those two clusters, and what I would be interested in, why is one of the CAs in Germany connected trust-wise to the rest of the world and the others are not? That might be something that you would never see if I just gave you some textual data, whereas here it becomes very apparent it's an outlier in the visualization. Here's another example that I stole from Chris Horsley, who is also a HoneyNet member. What he did is he has a bunch of sensors in his network where he collects network flows. Every color here is an individual sensor where he gets data from. And every individual rectangle here is a port number and how much activity I see per port. So port 445 seems to be very active here across all of his sensors. Now the other interesting thing he did is he uses the brightness of the color here to show if the brighter it is, the more traffic I had in the last 5 minutes on that port. So something very bright, I saw a lot of traffic in the last couple of minutes. If it's dark, I haven't seen traffic for that port in a while. Now if you see a certain port number light up here across all of the sensors, you probably have some global phenomenon like a worm starting to spread in your network. So that was an interesting way of applying color use in a tree map like this here. Now, visualization has a bunch of problems. To start with, it's hard to find the right data to visualize. A lot of people don't even collect the right data. I go to Fortune 500 companies in case of incidents, and I ask them, can I see the DNS logs, can I see HTTP traffic, and so on. And they don't have that collected. They're like, well, we can set a probe now to look at it. Well, it's a little late now. And then understanding the data, this is I think I stole this from one of Anton's presentations at some point. There's a log record that is in the Linux kernel shows up. I to date really don't know what it is. I'm not sure if you found out what it is. But it's some state change in the kernel, I think, at startup time or something, but the state changes from that number to the same number. So I have no idea what that means. Now multiply that by 100,000 if you look at 100,000 records and try to figure out what's really happening in the system. It's almost impossible. And then last but not least, we have too much data. What do we do with all of this data? Well, there's big data, right? Well, I saw this quote lately. Unfortunately, I don't remember the source. It says, memory has become the new hard disk. And hard disks are the tapes of yesterday. Right? We store everything on hard drives. We have so much memory available, it's insane. You buy laptops today that come stock with 8 gigabytes of RAM. I mean, back in the day, they had a DVD that only held 4 gigabytes, and now it's amazing what we can do today. Well, if you look at the big data environment, well, we have the capabilities today to deal with petabytes of data. The problem is just, what do we do with all this stuff, and what technology are we using? Are we using a column-based approach, a key-value approach, a document store, a search engine, a graph database? This stuff is complicated. There are so many different projects. Just going through those would probably take me an hour to explain to you all of the differences between that stuff. And then, if you have to do this data analysis for security, what do you choose? How do you do this stuff? And lately, I just read that the new release of MySQL actually now is also a NoSQL database. There's, through the Memcache APIs, you can now access the data without SQL. And so things are changing very rapidly. And it's really hard to figure out what technology is the right one to use for the problem that you have. Now, one of the fundamental problems is that if I give you a data set, or you give me one, it's probably a pretty large one. It's probably going to be in the terabytes, and you have to visualize it somehow. Well, often you end up with the hairball, literally. This is the hairball I generated with some visualization tools. It's useless, right? What do I do with this? How do I analyze a terabyte of data? Well, Ben Schneiderman, who is one of the luminaries in the visualization space, he actually invented the tree maps also that I showed you the network flow traffic. He came up with this concept where he said overview first, zoom and filter, and then details on demand. What he means by that is, if I give you a data set of a terabyte, you can't just jump in and take a certain detail, a certain piece of the data and visualize it. What you have to do is you start sort of with an overview like here, where I show you a histogram over time, and I have these 2 spikes in there, and I have a gap right after the second spike. And then you're like, oh, let me look at this one piece. Maybe I'm interested in the spikes. Maybe I'm interested in all of the other data where I don't have the spikes, because that might be what I'm interested in. And then I start selecting that. I might go and zoom in on that, take a different visualization, like a link node graph like here, start playing with that, iterating on that. And at some point, I realized, well, that top right cluster looks interesting. I wonder what exactly that is. And I have to go usually back to the original data to really understand what's underlying this little visualization there, and to be able to make a decision based on that. Now, Ben Schneiderman is really famous for all of this. I'm trying to make myself a name here as well. This is my kind of adoption of that whole experiment, or that principle, where I'm like, okay, that's fine if you have an overview and you start from there, but to continue, often what you need to do is you run some statistics or data mining on that data to boil it down to something manageable, because I can't deal with a terabyte of data in any way. I might have 20 different fields in my data, from source IPs to bytes to ports to URLs and usernames. I need to figure out what matters in here, what data is interesting, how does it cluster, how does it look. I need to run into some kind of data mining and start iterating with that, and zoom and filter, and find interesting properties here. Well, so data mining seems to be something that we need to look at. For those of you who don't know what data mining is, in a very simple way, it's the stuff that data scientists get paid the big bucks for, right? It's not easy. There are not a lot of people around the world that are actually good at this stuff. If you want a little more detail on what this is, in the textbooks you find sort of 6 categories of things that data mining really helps you with. The first one is the anomaly detection, so finding outliers. You give me a data set, and I'm trying to figure out what's normal in here, and then what's not really normal. What's the outlier in here, to figure out maybe whether someone is misbehaving, or a machine is suddenly behaving differently. That's incredibly hard, because if you come to me with a data set and I ask you, well, what's normal? You probably have a really hard time just defining that for me, because, well, user logins to certain systems, what's normal? Is it normal if they log in between 9 and 5? Or if they log in from a certain place all the time? Now they're traveling in a different time zone. Well, the time is different that they log in now. The location is different. How do you know about all these things? So that's still normal. How do you define abnormal then? Then there are other classes of problems with association rule learning, which is the sort of famous example here is the market basket. If you look at everybody shopping at a certain store, people generally buy certain things together, right? They might buy water and Coke together, and they might buy chips and potatoes together, or something like that. So there's certain things people always buy together. That's called the market baskets. And if you apply this to, for example, network traffic, you might see that there's certain things that always go together. There's always a DNS request right before there's an HTTP request, because usually people type in DNS names and you have to resolve them first. So there you can try to find these sort of market baskets and do analysis like that. There's clustering, where you take the data and split it into different groups that sort of look similar. It might be similar user behavior or something. There's classification, there's regression and summarization. Happy to talk more about that if anyone is interested. So the problem, though, not all of the data mining principles really apply to what I like to do with security data. I do not believe in anomaly detection algorithms, and we can have a long discussion if you want. I've seen a lot of research. It just doesn't work, because environments are changing too quickly. We don't know what's normal, and therefore we don't know how to detect the anomalous behavior. So what I like to do is I like to leverage data mining to augment my visualizations and improve them, so that a human analyst can look at them and make sense of them very quickly. I don't want to have the system making decisions for me, but I want to have the system help me as an analyst make a decision better. There's these 3 underlying topics here: data overviews, helping me understand what's the data about in general; looking at large populations, sort of separating things out, and then looking at high-dimensional data and helping me understand what dimensions actually matter in the data. That's the piece of how it breaks down. So if you look at data mining combined with visualization, I have a very quick example here. I have time on the x-axis here, so going over there in the future. And then you have users on the y-axis. And what I do here is every dot in here is user activity. The darker blue it gets, the more activity I have. So you see on the left-hand side here, there are some users that are active over the entire period of time that I'm looking at here. Some a little more active, some a little less. But I want to see sort of who has similar behavior in here. So what I did is, on the right-hand side, you see the same data, but this time I clustered it. So I'm using a clustering algorithm to group things together. And what you see is that on the bottom, for example, I have these users that seem to be very similar. Super active user on the bottom, and then users that are very active here, and then it gets lighter and lighter. And in the middle, I have all these users that are just sporadically active here every now and then. And then on top, I have a similar sort of band again, where I have the very active users, so I see these things suddenly splitting up into different clusters of users. Well, what you also see is one of the drawbacks of data mining and these clustering algorithms, which is that ideally I really want the top stuff to be together with the bottom stuff here, because they look very similar. But the way that the data mining algorithm, the clustering algorithm ran here, it started separating those. And that has to do with the distance function that was used here on the data to define how similar is something. And it's really hard to go in and tune these things to be correct for your problem. And in general, in data mining, there's a big problem in sort of applying these concepts to security data, because we're a little different in security. We're not like the physicists or the bioinformatics people, which have generally a lot of measures, where you look at temperatures that are numbers that 10 is bigger than 9 is bigger than 8. Or the bioinformatics people, they look at gene expressions and things like that, but they always have measurements, numbers that they can play with, and that's what the data mining algorithms were built for. But we, in security, we deal with categorical data, with usernames. Joe is not bigger than John or Jeff. We can't compare them that way. And it's really hard to deal with those categorical data in these data mining algorithms. We have to sort of adapt to that somehow. And there's still a lot of research to be done by the mathematicians and the data scientists. Now, so this is really what I'm working on in my day job, building a company around this whole idea of taking terabytes of data, helping you really understand the data through data visualization and data mining, which sort of creating the visibility, making it very simple for the security analysts, and helping the analysts also communicate with each other to start gaining insights into the data. Obviously, there's a whole bunch of secret sauce, but stay tuned for all that. With that, I'm happy to take a couple of questions. I think we have about 3 minutes left. Anyone wants to? Max.
To the clustering thing. Clustering is part science, part art.
Yeah.
And so, have you been working in that area to sort of try and make it a bit more predictable? It's often sort of like throwing chicken bones out and reading signs.
Yeah. So, have you been doing any work on sort of making that a more stable process?
So the beginning part, not everybody here probably was like that this clustering stuff seems to be a lot of voodoo and like throwing chicken bones at it. Have I done any work on making this more of a predictable thing? Well, I think again what we keep doing in the science world is we're running algorithms to come up the answers, right? We want to have this one clustering algorithm that gives us the perfect separation of all the data or clustering. Well, that's often not how it works. We have to build systems that are interactive, where I give feedback to the system starts learning, especially on the data that we have. It's so complicated, right? There are not many people that can go on and look at security data and really understand it. So we need to start building systems that are interactive, where we can play with data, and the system starts learning and gets better over time. That's what I'm looking at a lot. Yes? So the question is there any visualization tool that just helps you, any data that you have, like especially I guess in the HoneyNet context, to visualize that data and make sense out of it?
Yes, his name's Raffael.
Unfortunately, not really. There's a whole lot of open source tools out there that you can leverage to generate certain visualizations. The problem is every tool takes a different data format. You have to transform it first. Log data is very messy. It's not standardized. You have to parse it first, extract in different pieces in there. And I'm teaching workshops on that, on how to do that in like 3 days where you can learn all that. But there's really not a commercial solution out there that does it just end to end. Again, there's a bunch of open source tools, and we're working on things in the HoneyNet project to sort of build tools that standardize things. I guess HP Feeds would be something where you have a standardized format that comes out. Some people have Google Summer of Code have built visualizations. So there are individual pieces that are there, but there's nothing that you just plug in and it visualize the data and brings you all to all these insights, unfortunately. Okay, I think that's it, and I think lunch is ready. So, thank you.